This issue discusses the heliocentric legend and Kepler's three laws. Like the geocentric theory, the heliocentric theory was first proposed, is not the famous Copernicus. Rather, it was the greatest astronomer and mathematician of ancient Greece, Aristarchus. Aristarchus was born around 310 BC. It is recorded in the history of mankind, the first astronomer to advocate heliocentrism. He placed the sun, not the earth, at the center of the entire known universe. It is believed that the sun does not move with fixed stars, and the earth moves around the sun. Unfortunately, due to Aristarchus' cosmology and heliocentrism theory were far ahead of their time. Therefore, it was not recognized by the public at the time. So this advanced theory is like a precious one. The ring was thrown into the ocean and disappeared without a trace. Until the advent of Copernicus more than 1800 years later. 1473 Copernicus was born in the genus at that time Tarania, a small city in the Prussian province of the Kingdom of Poland. At that time, astronomy was based on Ptolemy's geocentric system. Thus, it can predict solar eclipses and lunar eclipses and can also explain some phenomena. But with the advancement of astronomical observation technology, it is found in Ptolemy's model of the universe. There are too many rounds to be attached to the planet's orbit to adjust the period of the orbit. To adapt the results of observations, in the Renaissance, the number of rounds and averages proposed by Ptolemy reached more than 80. This phenomenon aroused Copernicus's suspicions. He argues that if the sun is assumed to be the center of the universe, all other celestial bodies revolve around the sun, then there is no need to artificially add so many rounds of this round. But such a view was never dared to be put forward at the time. If the sun is the center of the universe, it would undoubtedly be considered heretical. However, Copernicus did not give up on scientific exploration because of external pressure. 1506, shortly after returning to China to teach, he began to write his own work on astronomy. Theory of the movement of celestial bodies. In 1512 Copernicus also took his place of residence in the castle. The Arrow Tower in the northwest corner was built as its own small observatory. Astronomical observations and calculations were carried out with rudimentary instruments developed by themselves. In 1514, for fear of persecution by the church, Copernicus published his model of the universe anonymously, i.e. the heliocentrism. His idea was that the sun was stationary at the center of the universe. Both the Earth and the planets are moving in a circular motion around the sun. The Earth rotates once a day, which forms the rotation of the celestial dome, whereas, the moon revolves around the Earth in a circular orbit. In addition, the annual motion of the sun on the celestial sphere, the regression or approach of planets observed by people on Earth. Phenomena are the result of the combined motion of the Earth and the planets around the Sun. Of course, the complete heliocentric system was published by Copernicus in 1543. It is elaborated in the treatise on the movement of the heavenly bodies. This book is also considered the starting point of modern astronomy. The idea that the Earth is in motion was difficult for the ancients to accept. In addition, the heliocentric theory states that the planets move in a circular motion around the sun. But the observations of planetary motion, this is not entirely consistent with the conclusion that the circumference is complete. Thus, more than half a century after the publication of Copernicus's treatise on the motions of the heavenly bodies, it wasn't until 1609 that Galileo Galilei used the newly invented telescope to observe Jupiter. Found. There are several small moons orbiting Jupiter. This shows that the celestial bodies are not all like Aristotle, directly moving around the Earth as Ptolemy believed. Almost at the same time, another astronomer, Kepler, improved Copernicus' theories, so that the theoretical predictions and observations are completely consistent at once. This completely declared the death of Ptolemy's geocentric system. When it comes to Kepler's three laws, we can't talk about the Danish astronomer Tycho Brahe. It is precisely because of reference to his large number of precious and accurate astronomical observations. Kepler finally studied and discovered the three laws of planetary motion. It laid a foundation for the discovery of Newton's law of universal gravitation. As an astronomy enthusiast, bright stars suddenly appeared in a constellation Cassiopeia. He made observations for months on end. Later it became known that this was not the creation of a new star. It's one so dark that it's almost invisible. The process by which a star explodes before disappearing. The discovered star is also known as Tycho's supernova. In 1577 a huge comet appeared over Denmark. For the first time, Tycho observed a comet as an independent object. Observations show that the comet's orbit cannot be perfectly circumferential. Rather, it should be elongated and judged by parallax between the comet and the Earth is farther than the distance of the Earth and the Moon. Tycho then underwent precise star position measurements, attempts to discover changes in the orientation of stars caused by the movement of the Earth, but it turned out to be nothing. Thus he began to oppose Copernicus's heliocentrism, and in the book On Comets, published in 1583, he proposed it. A theory that sits somewhere between geocentrism and heliocentrism, i.e. the Earth is the center of rest, the Sun moves in a circular motion around the Earth. Planets other than Earth move in a circular motion around the Sun. This theory was once accepted, and the Ming dynasty in China used the main basis. Occupy. Tycho's observations were compiled on the constitutional calendar. Although Tycho's planetary model was quickly phased out, but his astronomical observations were a major contribution to the scientific revolution. After Tycho's death, his assistant Kepler took advantage of what he had accumulated over the years. Observations. The three laws of planetary motion were carefully analyzed and studied, thus revealing the secrets of planetary motion. Kepler had conceived such a scenario for Copernicus' heliocentric system, i.e. if the planets are moving around the Sun instead of the Earth, there is no need to add any complicated rounds to adjust. In this way, the motion of the planets can be used very simply. Elegant track to describe. It can also explain the motion of the planets that do not conform to the circular orbit. Observations. On the basis of this assumption, Kepler referred to a large number of observations from Tycho. Material. Finally, the three laws of planetary motion were proposed. Kepler's first law, also known as the law of ellipse, the law of orbit. Each planet orbits the Sun in its own elliptical orbit. The Sun, on the other hand, is in one focal point of the ellipse. Kepler's second law, also known as the law of equal area. In the same amount of time, the Sun and the planets in motion, the swept area is equal. This means that the planets are far away from the Sun and sometimes close to each other. Kepler's third law, also known as the periodic law, the farther a planet is from the Sun, the longer its cycle, the squared of its cycle, and the more it goes. The distance between the suns is proportional to the cube. From this law can be derived the gravitational force between the planet and the Sun is inversely proportional to the square of the radius. This is an important foundation of Newton's law of universal gravitation. The planets move around the Sun in elliptical orbits, instead of moving around the Earth in a circular orbit. This conclusion directly confirms Copernicus's heliocentric theory. It also shows that the Earth does revolve around the Sun. A basically complete and correct description of the motion of the planets around the Sun is given. A fundamental problem in astronomy was solved. It also followed Newton's discovery of gravitation. The law lays a solid foundation. Isaac Newton once said, "If I see farther than anyone else, it's because I'm standing on the shoulders of giants." There is no doubt that Kepler is one of the giants to whom he refers.